Exercise 2.2, question number 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Starting with the first quadratic polynomial, which is x square minus 2x minus 8. So let's factorize this. This can be written as x square minus 4x plus 2x minus 8. Taking x common, we'll get x into x minus 4. Taking 2 common, 2 into x minus 4. This is equal to x minus 4 into x plus 2. So the value of x square minus 2x minus 8 is 0 when x minus 4 is equal to 0 or x plus 2 is equal to 0. That is when x is equal to 4 or x is equal to minus 2. Therefore, the zeros of x square minus 2x minus 8 are 4 and minus 2. Now let's verify the relationship between zeros and the coefficient. Sum of zeros is equal to 4 plus under bracket minus 2, which is equal to 4 minus 2 is equal to 2, or minus under bracket minus 2 by 1, which is equal to minus coefficient of x divided by coefficient of x square. Now product of zeros is equal to 4 into minus 2. This is equal to minus 8, which can be written as minus 8 by 1, which is equal to constant term, that is this one, divided by coefficient of x square. Now the second part. Second is 4s square minus 4s plus 1. Splitting the middle term, we will get 4s square minus 2s minus 2s plus 1. Taking 2s common, we will get 2s into 2s minus 1. Taking minus 1 as common, we will get 2s minus 1. This is equal to 2s minus 1 into 2s minus 1, or 2s minus 1 to the power 2. So the value of 4s square minus 4s plus 1 is 0 when 2s minus 1 is equal to 0. That is, s is equal to 1 by 2. Therefore, the zeros of 4s square minus 4s plus 1 are 1 by 2 and 1 by 2, since we have 2s minus 1 to the power 2. Now let's verify the relationship between the zeros and the coefficients. So for that, sum of zeros is equal to 1 by 2 plus 1 by 2, which is equal to 1, which can also be written as minus into minus 4 divided by 4. So here we can see the coefficient of s is minus 4 and the coefficient of s square is 4. So this is equal to minus coefficient of s divided by coefficient of s square. Now product of zeros is equal to 1 by 2 into 1 by 2, which is equal to 1 by 4. So our constant term is 1 and the coefficient of s square is 4. So this is equal to constant term divided by coefficient of s square. Third polynomial is 6x square minus 3 minus 7x. 6x square minus 3 minus 7x. Rearranging this, we will get 6x square minus 7x minus 3. Now splitting the middle term, we will get 6x square minus 9x plus 2x minus 3. Taking 3x common, we will get 3x into 2x minus 3. Here taking plus 1 common, we will get 1 into 2x minus 3, which is equal to 3x plus 1 into 2x minus 3. So the value of 6x square minus 3 minus 7x is 0 when 3x plus 1 is equal to 0 or 2x minus 3 is equal to 0. That is, x is equal to minus 1 by 3 or x is equal to 3 by 2. Therefore, the zeros of 6x square minus 3 minus 7x are minus 1 by 3 and 3 by 2. Now let's verify the relationship between zeros and the coefficients. So sum of zeros is equal to minus 1 by 3 plus 3 by 2, which is equal to 7 by 6. 7 by 6 can be written as minus into minus 7 divided by 6. So the coefficient of x is minus 7 and coefficient of x square is 6. So this can be written as minus coefficient of x divided by coefficient of x square. Now product of zeros is equal to minus 1 by 3 into 3 by 2, which is equal to minus 1 by 2. So this can also be written as minus 3 divided by 6. Minus 3 is our constant term and 6 is the coefficient of x square. So this is equal to constant term divided by coefficient of x square. Now the fourth polynomial. Fourth is 4u square plus 8u. Taking 4u common, we will get 4u into u plus 2. So the value of 4u square plus 8u is 0 when 4u is equal to 0 or u plus 2 is equal to 0. That is u is equal to 0 or u is equal to minus 2. Therefore the zeros of 4u square plus 8u are 0 and minus 2. So now let's verify the relationship between the zeros and the coefficients. So sum of zeros is equal to 0 plus under bracket minus 2, which is equal to minus 2. Minus 2 can also be represented as minus under bracket 8 divided by 4, which is equal to the coefficient of u is 8 and the coefficient of u square is 4. So this is equal to minus coefficient of u divided by coefficient of u square, and product of zeros is equal to 0 into minus 2, which is equal to 0. So this can also be represented as 0 by 4. So here we have our constant term as 0. and the coefficient of u square is 4. So this is equal to constant term divided by coefficient of u square. Now the fifth polynomial. Fifth polynomial is t square minus 15. This can be written as t square minus square root of 15 to the power 2. Now using formula a square minus b square, this can be written as t minus square root of 15 into t plus square root of 15. So the value of t square minus 15 is 0 when t minus square root of 15 is equal to 0 or t plus square root of 15 is equal to 0. That is when t is equal to square root 15 or t is equal to minus square root 15. Therefore the zeros of t square minus 15 are square root of 15 and minus square root of 15. Now let's verify the relationship of zeros and the coefficient. So sum of zeros is equal to square root of 15 plus minus square root of 15. This is equal to 0, which can also be written as 0 by 1. So in this polynomial we can see the coefficient of t is 0 and the coefficient of t square is 1. So we can write minus coefficient of t divided by coefficient of t square, and product of zeros is equal to square root of 15 into under bracket minus square root of 15, which is equal to minus 15. This can be written as minus 15 by 1. So minus 15 is our constant term and the coefficient of t square is 1. So this is equal to constant term divided by coefficient of t square. Now the sixth polynomial. Sixth polynomial is 3x square minus x minus 4. 3x square minus x minus 4. Splitting the middle term, we will get 3x square minus 4x plus 3x minus 4. Taking x common, we will get x into 3x minus 4, and from these two, taking plus 1 common, we will get plus 1 into 3x minus 4. So this is equal to 3x minus 4 into x plus 1. So the value of 3x square minus x minus 4 is 0 when 3x minus 4 is equal to 0 or x plus 1 is equal to 0. That is when x is equal to 4 by 3 or x is equal to minus 1. Therefore, the zeros of 3x square minus x minus 4 are 4 by 3 and minus 1. Now let's verify the relationship between zeros and the coefficient. For that, sum of zeros is equal to 4 by 3 plus under bracket minus 1, which is equal to 1 by 3. This can also be written as minus into minus 1 by 3. So from here we can see that the coefficient of x is minus 1 and the coefficient of x square is 3. So this is equal to minus coefficient of x divided by coefficient of x square. Now product of zeros by multiplying these two, we will get 4 by 3 into minus 1, which is equal to minus 4 by 3. So from here we can see that minus 4 is our constant term and 3 is coefficient of x square. So this is equal to constant term divided by coefficient of x square.